next speaker has tons of experience, right? Arafat has a goal to be on the core team of Golang. It's a pretty good goal to have, right? Actually, hang on, I'm searching for him. Oh, there he is. There he is. Come on over. He loves to wear his hat, his cap. Bill, you have a follower? And now he knows how to reach his goal. All right, so he loves hiking, kayaking, ice skating, loves falling down when he's ice skating, inspiring others to wear helmets, right? While he keeps wearing a cap. He loves to code. He shuttles between Canada and India. He's in, you said you're in IIT Kharagpur, right? Yeah, so he's in IIT Kharagpur. Wants to keep learning Go, and he's going to talk a lot about algorithms. And we are good to go. Awesome. Clap, please.
Okay. So, all right. Hi, Gophers. Really nice to meet you guys. Thank you so much for coming all over from the country and from across the world. So, I am Arafat, and a little bit of me before I start this conference. So I'm from this beautiful state called Rajasthan. It's a really nice place, and I think all of you should visit it once in your lifetime. I have a gopher that describes my homeland really well. So I guess this might resonate with some of you. So it's a Rajasthani gopher. I love coding. Originally, I'm from Ruby conferences, so that's where you'd usually find me, but I also like Golang, and I built something cool in it, so that's why I came here. And I love hiking. This is one of my favorite shots. I took it in the beautiful British Columbia. And that's about it. So let's start. So this talk is about visualizations in Golang. So again, this is kind of a contrary to the popular topics. And part of the reason why I'm doing this is because I came from the scientific programming community. And in that, everything you do in MATLAB or like SciRuby or whatever, you always have to have some visuals. I didn't see any of those things in Golang, so I tried to build something for myself. So the philosophical reason behind doing any visualization in Golang is visualization gives you answers to questions that you didn't know you had. And I guess as we go through this talk, this will become abundantly clear to you guys. So, okay, all right. So before I do anything, I just want to ask you guys, how many of you like giving programming interviews? Like, how many of you have you all given programming interviews? Okay, so there are like a few people, but almost everyone doesn't like programming interviews. Color me surprised. But yeah, right. But they're really important. They're really important as a software developer, and I think you should focus on improving your interviewing skills and things like that. And I have a favorite quote on interviews, which goes something like this. So this is from Max Howell. He was rejected by Google, and he got pissed off, so he posted on Twitter. Fair enough. So again, I'm not judging on like which is the right way, which is not the right way, but I'm just going to offer you one perspective on how you can conduct interviews and how you could do something about it. So when I came to Golang, I wanted to build something cool. I wanted to build something that would help people play around with data structures. So I built a library that has a lot of different data structures like list, stacks, and like B trees, things like that sort, and you can visualize them. So today, in particular, I'm going to be talking about priority queues, and priority queues can be implemented in many different ways. I'm just going to show you one way to implement a priority queue, and then we will see like how, if you were hypothetically a student or somebody who was a new learner, you could use this library to really understand priority queues. So priority queue is a queue data structure with some additional properties. It's every item has a priority associated with it, usually an integer. An item with a higher priority is dequeued before an item with a lower priority, and two items with an equal priority are dequeued based on their order in the queue. So how do we implement it? How do we go about implementing this? So we're going to use a binary heap. We're going to use binary heaps to implement a priority queue this time. So binary heaps are efficient ways of implementing priority queues, and main reason is that the element maximum minimum takes off one time, and the insertion deletion takes logarithmic time. So let's just help you understand how binary trees are before we do the visuals. So a heap is a binary tree with two special properties. It must have all of its nodes in a specific order, and its shape must be complete. Let's take a closer look at what this means. So the two rules of heaping. The first one is the shape property, that the heap must be a complete binary tree. This means that all of the levels must be completely filled, except maybe the last one. So what does that mean? So if you look at this one, this whole tree is completely filled. All of the nodes are filled, and on that one, that is also satisfying the shape property, because for the last level, it's filled from the leftmost node. So these two nodes are satisfying the shape property. This is the first property of a binary heap. The second one is the order property. So you either have an increasing order or decreasing order. So this is sort of an increasing order. If you look at any node, its children node are greater than the node itself. So if you look at, say, 2, 4, and 5 greater than that, and if you look at, say, 6, 12, and 13 are bigger than that. So it's always following an incremental order, no matter how you go from top to the bottom. And so that's the order property. So you need to have these two properties, and then you can look at a binary tree, and you can go, OK, this satisfies the heap property. So these are the two rules of heaps summarized. And so if you look on the right one, that is satisfying the shape property, but the left one, that is not satisfying the shape property because it's not completely filled. So how do we even make a heap? How do we even make a heap? So the idea behind construction of a heap is an inductive idea, that you do it in an inductive fashion. You keep one base node, and then you keep adding more nodes to that base node so that you follow these properties inductively. So you keep a base node, and then you add another node to it. So let's say you have an existing binary tree. And this is, say, this satisfies all your properties, satisfies the shape property and the order property. And you want to add another node to it, which is, say, 43 in this case. So we'll add it at the leftmost place. That's the first thing. And the second thing is the order property. It's still not satisfying the order. So you can see that this is a decreasing order. From here to here, it's decreasing, decreasing, but it's not decreasing here. So what you do is you take an incremental jump upwards. It's called a bubble up operation. So this way, you could sort of, on a base heap, you can increment it, add nodes, and then you'll have like a complete heap. So you could represent the heap as an array. And generally, when you implement it in C, C++, whatever, you generally implement it as an array. So the whole thing that you're seeing right now, if you go like from 43 to like 1935, then 12, 4 to 20, 12, 4 to 20, and then 6. So you go in different lines, like horizontally, and then vertically, you have your heap implemented as an array. So, right, so we've done that. Let's write some code. Let's try to see how this actually works in a real library. So, right, so we're pulling binary heaps from database library, the one that I wrote. We're defining a heap, and we've got an interface array with a set of integers. These integers are not in any order. And then when we're going to do sorting with the heaps. So every time you're doing a for loop, and you're pushing these integers in the tree. So let's see what happens when you do that. Right, so you can see that as you're pushing the numbers in the tree, it's growing incrementally. And it's satisfying all the properties as you add more numbers to it. So again, and then after, like, it helps you sort of visually see how, like, the construction and how sort of this whole binary tree data structure works. You could see, like, it's growing incrementally. And at the end of this whole thing, you just pop all the elements from the binary heap, so you get them sorted out. So it's kind of easy to use. And then there's the other argument, which is like, OK, you can sort of visualize it. You can see how it looks like, but how do you really understand it? So you go to the definition, and you can see that it's really, I went out of my way to make sure that the definition was very well documented and very easy to understand. So if you're a student and you're trying to learn these things, it's going to be super easy for you to sort of, you look at the push and pop operations. They're really kind of well defined to the best of my knowledge. But and then after that, we can sort of shrink heaps. So shrink is the operation that helps you sort of figure out how to sort the heap and how the heap will look like after you take out one node from the top every single time. So, okay, so let's do a visual. So let's say we've got some numbers, and we built a binary heap from those numbers. So how do we do the sorting? So it looks something like this. So the numbers from the top go and get in there. So you take it from the top, it goes over there. That's one way to sort. So this is probably a good and easy way to understand this data structure. Aside from that, this is not the only thing we can do. We have a lot of different data structures too, right? So let's look at something else. So, okay, so anybody know what these guys are, what the right one thing is? I'm sure you guys know. Can anybody just yell out loud like what the thing on the right is? Yeah, red, black tree. And what the left one thing is? Does anybody know what that is? It's, you use it all the time. You use it every day. You're probably using it right now for something. So it's a B tree. It's a B tree. It's used in the internal implementations of databases. So if you ever want to like look up how B tree works and implements, you can just go to the library and just get the code. And it's honestly surprisingly simple, but. Right, so this was the first part of the talk. This was like sort of the starting part of the talk. And let's conclude this database thing. So the thing is, the idea is if you want to get jobs, you got to be good at interviewing. If you want to be good at interviewing, you need to learn data structures and algorithms. And if you want to learn data structures and algorithms, you need to use my library database. So that's the argument. Yeah. So try it out. It's pretty cool. It's gotten really popular on GitHub, so that's good. And I've written an article on Medium, so that's great for your intro. Let's visualize a different problem now. So now that we're done with the database thing, let's visualize a totally different problem here. So machine learning, as you guys know it's really popular. And it's so popular, I'm not even going to make a convincing argument as to why you should even bother trying to learn machine learning. So, I mean, you guys are using it. It's pretty cool, and it's fun. So we sort of, when I came to Golang, I was a bit disappointed that we didn't really have something for it. We didn't have some visualizations and things like that for Golang. So I built another thing for myself. So the main reason I did that was because in the summer of 2016, some really nice people at Google were building TensorFlow in Golang, and I was really involved in the community. In parallel, I was developing TensorFlow for Ruby. So I'm the author of TensorFlow for Ruby, and that's why I speak at Ruby conferences. So that is really one of the things that I feel like I might be good at. And OK, right, so coming back. So I wanted to build sort of like a library that just does like these simple visuals of some simple data. You take it something like, say, scatter plot, line plot, bubble plot, things like that. You've got all these plots. And if you have like used MATLAB or Matplotlib in Python, you realize how easy these things are. But more importantly, the idea is that they help you tell a story. And rather disappointing thing was Golang didn't have anything for that. So I tried to make one for myself. So let's solve a problem for it. I made the library called Glot. It's based on the backend of GNUplot. And let me show you a problem, and then we'll try to solve it. So, all right. So we've got a simple problem. We have the area of a property in square feet, in 1,000 square feet. And we've got the price of the property in million Indian rupees. So again, we could see a really nice scatter plot. And our goal here with this problem is that we want to be able to make a best fit line that passes through this whole thing, and that gives us the best indicator of what would be the correlation between the area of the property and its price. Again, it's a pretty standard problem, nothing out of the world, but we can still do this in Go, and that's pretty cool. So let's see how we can do this in Go. Okay, so we're going to use linear regression and gradient descent. These are like fancy sounding words, and they're pretty cool. But we could do that. We could do that with matrix operations. We could do that with differentiation and things like that. And then you would get like the perfect, most mathematically accurate solution that's acceptable everywhere. And you can do that as a mathematician. But if we want to do that, we're not mathematicians. We're programmers. So we're going to do it in simple programming fashion using a much simpler algorithm and have a visual while we add it. So initially, the idea in gradient descent is that you take an initial best fit line. So what I'm claiming here is that this line, this green line that you're seeing, this is the best fit line for this data. And this best describes the correlation between the area and the price. Now, clearly, this does not look like a best fit line. It looks like an aberration, to be honest. It's not a best fit line. So how do we get this best fit line to the best solution? So what we do is like we use gradient descent. Gradient descent algorithm has the idea that every solution that you get for a machine learning problem has a loss function. And in different iterations, you could reduce the loss function to get the best possible solution. So if you look at this line in particular, this line has a very high loss value. It's not a good solution. What we want to do is we want to do different iterations to improve this solution to get a global loss minimum. So we've got a few things here before we try to implement it. We've got a few things. So the first thing is like we've got a hypothesis function, which is a line, which is the best fit line. So the equation of a line is theta 0 plus theta 1 times x. That is the hypothesis line, the green line. The second thing is the mean squared error. There are many different ways to take errors. We're going to take the mean squared error. And then the gradient descent function, which is a differentiation-based function, which helps you iteratively change the equation of the line, the hypothesis function, to figure out what would be the best possible solution for ourselves. So we're going to use gradient descent to iteratively figure out the best solution for this. So let's jump to the code. So we've got the first row line is pretty simple. We're just taking in the data from a file. Then we define the iterations. The iterations are basically these things in here in the gradient descent. We take different iterations. In every different iteration, we're trying to improve a solution by a little value. And we're getting to lowering the loss function in different iterations. So we define 1,000 iterations so that you could see how the solution improves in different iterations. And then we define like alpha, which is like the changing coefficient, and then the equation of line, theta 0, theta 1. So we apply the gradient descent function here, we get a cost. And in every 100 iterations, we're printing what would the solution look like, so that we could watch how the solution incrementally grows to the best possible solution. Stop. Right, so initially we've got the line, and then it jumps, and then the solution, oh, wait. I think I should do a bit of a zoom in thing. Right. So we've got, initially the line is horizontal, then after the first iteration it jumps. And if you look at the star above, if you look at the top star, this one in particular, you could watch how the solution is improving in different iterations. So, and then if you look at the bottom, you watch the loss function. So initially it was 64, and then it was like improving and incrementally getting downwards and downwards and downwards. So that's how you could sort of visualize a problem in GLOT, and it's basically an overlay of a line plot over a scatter plot. So let's look at how we built the plot. So in the plot, we defined a new plot. We defined the data points, all these data points. These were static, so we kept them fixed. Then we were overlaying the best fit line. So we defined this line as the equation of a line we defined here. And then we added, like, we kept the starting points and the ending points, and we just drew the line. We defined the labels on the x and the y axis. And in every different iteration, we're updating our plot. We're updating the equation of line. So that's how we get this whole plot thing that iteratively changes. So again, we could solve this problem, but is that all? Is that really all we can do with this software? And the answer is obviously no. We can do a lot more things. We can plot sine curves, cubic curves, exponential curves, charts of different types. And it's not as nuanced or as evolved as something like Matplotlib. But if you're a student and if you're trying to do something basic, this is the way to go. So try to use it in Golang. So let's conclude. Visualizations are an important tool, whether you're using ML algorithms and data analysis, and combining data and its interpretations with plots and visualizations is a great way to improve your understanding of things. And the most important lesson here is that Golang can be used for this too, so we don't have to run away from it. And we as developers must learn this other aspect of Golang to be better as developers. Right, so that's about it. Thank you so much.
All right, thank you, Arafat. Questions? You can ask about anything.
Oh, no, not really. No.
All right. A loud round of applause for him. Thank you so much.